Hi, welcome to the video. My name is Pushpinder Gill, and today we're going to do time, speed, and distance part 2, right? So, this over here is my email address where you can send me your valuable feedback. That is pushperfectscores89 at gmail.com. And if you think this video helped you, just make sure that you like us at facebook.com/perfectscores. And to explore more about us, keep watching this page that is perfect-scores.com, right? So there's more to come here. So today we're going to do time, speed, and distance part 2. We already done part 1 wherein I have discussed about the variations in time, speed, and distance according to one another. So in the second part, we're going to discuss, that is this part, that is the relative speed, that is the speed of objects with each another, right? So don't get too confused by this, with this big term as relative speed. It's very simple concept, right? So let's go ahead and move forward and understand that. Now, what exactly is relative speed? So as I said, relative speed is the speed of bodies. So relative speed is the speed of bodies according to each another, right? So it's the speed of bodies according to each other, right? So that's what the meaning of relative speed is. So let's suppose there are two types of relative speeds which can happen. The first type is when the bodies are traveling in the same direction. So let's suppose this is let's say this is car A, right? So I don't know how to draw a car, right? So let's suppose this is car A, which is traveling at the speed of 10 kilometers per hour. So this is car A, and let's suppose this is over here as car B, which is actually traveling at 20 kilometers per hour, right? So the relative speed over here would be, what do you mean by relative speed? Speed is the actual distance that is covered between these two cars in 1 hour, right? So this car covers 20 kilometers per hour. This car covers 10 kilometers per hour. So the actual distance that will be covered between these two cars, that would be 20 minus 10, that is 10 kilometers per hour. Why is that? Because this car is gonna cover 20 kilometers and this A car is gonna cover 10 kilometers, and the distance between them is always gonna remain 10 kilometers every hour. So every hour 10 kilometers per hour is gonna get added between these two cars. So when the cars travel in the same direction, or whenever two objects travels in the same direction, if the speed of one object is A and speed of another object is B, so the distance that they're traveling, so the overall relative speed is A minus B kilometers per hour. So that's what the speed is, A minus B. The speed get deducted, right? So let's see the another part of the story, that is when they travel in opposite directions. So what do you mean by opposite direction? Let's suppose this is car A, all right, and let's suppose this is car B, and car A is traveling at 20 kilometers per hour and car A is traveling at 10 kilometers per hour. Now what is happening every hour? Every hour A is traveling 20 kilometers and B is traveling 10 kilometers. That means every hour a total distance of 30 kilometers is being traveled, right? So this is what is happening every hour. So when the objects are coming towards each other, or when the objects are in opposite directions, so that means that the speeds are going to get added, right? So that means this is what the relative speed is equal to when the objects are traveling in opposite direction, right? So suppose you must know about this, in the very beginning of this video. That's why I'm not wasting too much time on that. So when the cars travel in the same direction, the speeds get deducted, so there is a subtraction involved, and when the cars travel in the opposite direction, the speeds get deducted, so the speeds get added, there is an addition involved, right? So I suppose you already know that. But what is it there to GRE, GMAT, and CAT? What is there to standardized testing, right? So let's go ahead and use that, right? So I'm gonna pick up a very easy question, and on that easy question I'm gonna apply some technique which I'll tell you in the just next slide. So over here it says that car A on a straight road travels from point A towards point B at an average speed of 60 kilometers per hour. So there is, let's say, a point A, and there is, let's say, a point B, and this is the distance. Car A travels from here at the speed of, so this is, let's say, the speed, at the speed of 60 kilometers per hour. And it says that at the same time, car B in the opposite direction of car A starts from point B towards car A at an average speed of 40 kilometers per hour. So car B travels at an average speed of 40 kilometers per hour, and if they meet after 20 minutes, what is the distance traveled? What is the distance between point A and point B? So let's suppose they meet here, right? So let's suppose this is that point. So which means what? That means car A has traveled from here till here, and car B has traveled from here to here. That means in this particular, when they meet, the time is actually which is constant, right? So the same time they have traveled the distance, so time is something which is constant. At that particular time, A has traveled some distance and car B has traveled some distance, but the total distance is actually equivalent to the distance between A and B, right? So that's what the case is. So it says that they meet each other after 20 minutes. So the time over here is actually 1 by 3 hours, right? So 20 minutes is 20 by 60 minutes, 20 by 60 hours, which is 1 by 3 hours. Again, the time here is 1 by 3 hours, and the distance traveled is equal to speed into time, which is equivalent to 20 here, and which is equivalent to 40 by 3 here. So the total distance is equal to 20 plus 40 by 3. Since there are no answer options, so I'll suggest this as my answer. So the only thing that I want to emphasize over here is that always find which thing is constant. That is something that will make sure that you get your answer right. Always find something that is constant. You know what? Sometimes the distance traveled is same, sometimes the time taken is same, sometimes the speed is same. So you gotta always identify which thing is same, and always work in columns in the same way which I have done. The distance is equal to speed into time, and over here are going to be equal to your different cars or different persons or different people, whoever they are. So this actually keeps you organized, which is actually what I want. And you know what, GMAT, GRE or CAT, take it any test, it is not going to test your, too much. It's not going to test your concepts. It's not going to test, what techniques you have. It's going to test how organized you are. This is what is majorly tested. So if you are organized in your scratch paper work, you are never going to go wrong. Believe me in that. What I have and what you have, it's just scratch paper work that we have. So you got to stay organized in that so that you don't make mistakes. That is very, very crucial. I would actually give it 5 stars, right? So always make sure that your scratch paper setup is actually organized. So I will give it 5 stars to your scratch paper setup, right? So alright, so let's move forward to a question. Okay, now always find what is constant in the question. This is very, very crucial when it comes to relative speed. Always find what is constant, and you'll be surprised many times that so easily you're able to get the answer, right? Now let's see this question. It says that Candy started from home on a trip averaging 30 miles per hour. So this is Candy here, and I already know that the distance is equal to speed into time. This is something that I already know. It says that Candy started from home averaging at 30 miles per hour. How fast must Julia drive to catch her up in 3 hours if she leaves 30 minutes after Candy? So what is the distance that Candy is going to travel in those 30 minutes? So the distance that she is going to travel will be equal to 15 miles, right? So now right over here, it's right over here is Julia, and the distance between them is 15 miles, and right over here it's Candy, and they are both traveling in the same direction. And now what is the question saying? The speed of Julia is 30 miles per hour, and let's suppose the speed of Candy is 30 miles per hour. Let's suppose the speed of Julia is j miles per hour. and the distance between them is 15 miles. So the relative speed is going to be equal to, so what is the relative speed here? It's going to be equal to, so since Julia has to catch up Candy, so Julia's speed has to be greater than Candy's speed, so that will be J minus 30, and the distance between them is actually equal to 15 miles. So the time taken from here is actually equal to distance by speed, which is 15 upon J minus 30, which is actually equal to 33 hours, right? So not 30 minutes, 3 hours, which is actually equal to 3 hours, right? So this is what is given in the question. So if I say 15 is equal to 3J minus 30, right? So from here 3J actually becomes 45 and J actually becomes 15. So this becomes 45 and sorry, this is 30 into, sorry, it's 3J minus 90, right? So just a small calculation error, right? So um, 3J minus 90, so this is going to be 90 plus 45, 90 plus 15, which is going to be equal to 105. So J would be 105 divided by 3, so that would be equal to 3, and 1 and 5, that is 35, so 35 is my answer, right? So suppose you've understood this question, just a little calculation error at the end. That the speed is 30 and in half an hour is going to travel 15 miles, so the distance between them is 15 miles. So Julia travels at the rate of J miles per hour and Candy travels at the rate of 30 miles per hour. So the relative speed is J minus 30 and the distance between them is 15 miles. So the time taken is going to be 15 divided by J minus 30, which is equal to 3 hours, which is given in the question. And from there we calculate the speed of Julia, which comes down to be equal to 35 miles per hour, right? So suppose everyone has understood the question. Let's go ahead and move to the next one. Now let's see this question. It says that Arun, Baron and Kiranmala start from the same place. So let's suppose this over here is the place. Let me get my pen. So let's suppose this over here is the place where they actually start from. So there is A, there is Arun, there is Baron and there is K. So they actually start from the same place in the same direction at the speed of. So this over here is your speed, that is going to be equal to 30 for A, 40 for B and 60 for C. This over here is your speed. Now it says that Barun starts 2 hours after Arun, right? So Barun over here, so Arun is the one which actually starts first, and after 2 hours it's actually Barun starts. Now the question is saying if Barun, Kiranmala overtake Arun at the same instant, how many hours after Arun did Kiranmala start? Now understand, this over here is actually a twisted question. It's a previous CAT question also, so supposed to be tough. Now this over here is it's a cricket question. Why is that? Because it's actually asking you to back solve. This is a very good contender to back solve. So what do we do when we back solve? Is actually we start with answer option C and we move up or down accordingly to the question, right? So let's suppose Kiranmala actually started 4 hours after Arun, right? So if it started 4 hours after Arun, that means the distance between Kiranmala and the distance between Arun when Kiranmala started would be equal to the distance that Arun has traveled in 4 hours. So the distance that Arun has traveled in 4 hours is going to be equal to the speed of Arun into the time, that would be equal to 120 miles. So the time taken for Kiranmala to catch Arun would be equal to the total distance between them divided by their relative speed. Now what is their relative speed? That is 60 minus 30, which is equivalent to 30, that is 4 hours. So the time taken for Kiranmala to catch Arun would be 4 hours of alone that Arun traveled and 4 more hours that it took Kiranmala to catch Arun. that would be 4 plus 4, which is 8 hours, right? Now let's actually calculate how much time did it take for Barun to actually catch Arun. Now what was the distance between Barun and Arun when actually our Barun started? So he actually started 2 hours later. So in those 2 hours, Arun would have traveled 30 into 2, which is 60 miles. And when Barun started, the relative speed is actually equal to this minus this, which is actually equal to 10 since they're traveling in the same direction. So it took 6 hours for Barun to catch Arun plus 2 more hours when actually Arun was traveling alone. So it again took 8 hours for Barun to catch alone. That means after 8 hours, what was happening? All three of them were actually at the same spot. And this is what the question is asking you, right? That means answer option C is my answer, right? So I suppose everyone is understanding over here what I'm trying to do. It's just I'm trying to back solve. And if I would have gotten a discrepancy over here, if this would have been 8 and this would have been 7, then I'll just move up and down accordingly, right? So I'm lucky over here that answer option C is my answer. And you know what? If you follow the right technique and if you follow the right method, you're gonna seem that you are too lucky in the test. Why is that? Because these questions actually help you to solve the questions. They are not difficult at all. So what you have to do is you just have to trust your instincts and trust that these questions are going to be easy for you, right? So whenever you back solve, just start with answer option C. Suppose you must have watched the video on back solving as well, so that actually tells you how do you back solve. So always start with answer option C and move up and down accordingly, right? You can also do this question using algebra, but I feel that you can actually do this question with back solving much easier, right? So I suppose everyone has understood this. All I have done is I've just assumed that K started 4 hours later than A, and I did just solved and I calculated the hours and they came to be equal, which was given in the question, right? So let's go ahead and move to the next question. Now let's go ahead and do this question. It says that there are two trains, alpha and beta, running in opposite direction on a circular track. So let's suppose this is the circular track. Now it says that train alpha travels at the rate of 4 miles per hour. So this is your train alpha, right? And its speed, it's 4 pi miles per hour. And there is train beta, but actually travels at the speed of 6 pi miles per hour. If the radius of the track is 6 miles, so the radius of the track is 6 miles, and the trains both travel from point delta. So let's suppose this is the point delta. That is what they start from at the same time, right? And it's already given in the question that they actually travel in opposite direction. So let's suppose alpha travels in this direction and beta travels in this direction. Now the question is saying that how long in hours after the train departs they meet again at point delta. So this is what the question is asking. The question is asking when they are going to meet at point delta, right? So that's what the question is asking. So they have to actually meet right here, right? So what is the distance that to be traveled when they start from this point and they actually end at this point? That would be the circumference of the circle, right? So what is the circumference of the circle? That is 2 pi r. That would be equivalent to 2 into pi into 6, which will be equivalent to 12 pi, right? So this over here is the circumference of the circle, right? So let's see the time taken for each of the trains to travel the whole circular distance. So the distance over here is actually equal to 12 pi. It's actually equal to 12 pi. So the time taken over here would be distance by speed, which will be 3 hours, and distance by speed, which will actually be 2 hours. So every 3 hours car A will be here, and every 2 hours the train B will be here. Now when they are going to be here exactly at the same time is the LCM of 3 and 2. Why is that? Because for the first 3 hours, car 3 is gonna be here, it's gonna be at the 6th hour, it's gonna be at the 9th hour. Similarly for alpha, for the train beta, after every 2 hours it's gonna be here, after every 4 hours it's gonna be here, and after every 6 hours it's gonna be here. So you can clearly see 6 is the something which is common to both of them. That means after every 6 hours, or after 6 hours, or after 12 hours, or after 18 hours, or 24 hours, they are going to meet at the same point, that is from that they started. That means they're going to meet the first time in the first 6 hours. That means my answer is option A, right? So I suppose everyone has understood the question. It's not a difficult question at all, but you know what? It's actually a tough question when it comes to GMAT. So it actually the cars actually starts from here, and they travel at this rate of 4 pi per hour and 6 pi per hour, and so the time taken for so train alpha to cover the whole distance is 3 pi, and time taken for time beta to cover the whole distance is actually 2 pi, and they the time when they actually both meet right at this point is actually the LCM of these 2 points, that is equivalent to 6 hours, right? So suppose everyone has understood this question. So let's go and move to the next one. Now let's go and do this question. Now again, it's a previous CAT question, that means ought to be difficult, but let's see how difficult it is. Now it's a previous CAT question. It says that Ram and Sham run a race between point A and point B, that is 5 kilometers apart. So this is point A and this is point B. So the distance between these 2 points is 5 kilometers. And it says that A travels at the speed of, so A travels at the speed of 5 kilometers per hour, and B travels at the speed of, that is given in the question, that is 10 kilometers per hour, right? So that's what the speed of B is. Now the question is saying that A starts at 9 a.m. and B starts at 9:45 a.m. Now from 9 a.m. to 9:45 a.m. in these 45 minutes, that is in this 3/4 of an hour, right? So that's what it is. How much of the distance has car A traveled? Because car A is the one which actually started first. So the distance traveled would be the speed of car A, that is 5 kilometers per hour, into the time is, that is 3 by 4 hours. That is going to be equal to 15 by 4, which is equal to 3.75 kilometers. So this is the distance that car A has traveled, that is 3.75 kilometers, when actually car B started from here. So when car B started from here, that is the distance between them was 3.75 kilometers per hour. Now but over here, car A is actually go from here till here, and it's actually supposed to come back, right? So the question is asking at what time Ram and Sham meet for the first time. Now the distance remaining over here is 1.25 kilometers. So what is the time taken for car A to travel this 1.25 kilometers? So the time taken for it to travel this 1.25 kilometers, that would be 1.25 divided by the speed of car A. So that would be equal to this divided by the speed, that is 5, right? But in that time, car B would also have traveled some distance. And what would be that distance? That would be speed into time. So distance is equal to speed into time. I suppose everyone knows that. So what is the speed of car B? So speed of car B is actually equal to 10, and the time taken for car B to travel anything, that would be the time taken, which is equivalent to for car A to travel from here to here, which would actually be equal to 1.25 divided by 5. So this is nothing but the distance traveled by car B from here to any point here, which is actually equivalent to this. So car B is something somewhere here, right? And car A is exactly right here. Now, what is their relative speed? Now, car B is traveling this way and car A is traveling this way. So, their speed is nothing but 15, which will come in the denominator because time travel is distance upon speed, right? And what is the distance between them? So that is what we have to calculate, the distance between them. So if we calculate this decimal goes away and it gives us 100 at the bottom, and this is 25 times 4 and 25 times 5, and this goes away, so this is 2 times 5 and 2 times 2, which is nothing but 2.5 kilometers. That means car B is somewhere here. That means the distance between them is actually 2.5 kilometers and the relative speed is 1.5. That means the time taken for them to meet would be 2.5 by 15 hours. So if we calculate the actual time, that is the time taken for car A to travel from here to here, and then time taken for it to travel back and meet car B, that would be actually equivalent to this. So if I just multiply this by 3 and if I multiply this by 3, so that would be 3.75 plus 2.5 divided by 15. So if I had to calculate 3.75 plus 2.5, so that would be 3.75 and 2.5. So that would be 5 and 2 and 3 plus 1 is 4, that is 6.25. So 6.25 divided by 15, right? So that would be equivalent to 625 by 100 into 15. Now this is something that I'm going to get in hours. This is something which is in hours. Let me actually try to calculate that in minutes, right? Because this is something that is actually starting from 9 o'clock, so I have to actually get that in minutes. So let's actually multiply it by 60. So if I multiply by 60, this goes by 15 times 4, that is 60. 25 times 4 and 25 times what do you call it, 25, and 4 and 4 go, so that actually gives me 25 minutes. So right from here and here, right? So what is the time for car A to reach from here to here is actually equivalent to 1 hour, which is going to be equal to, so sorry, it's going to be equal to 9 hours, sorry, from here to here, that would be 9:45. It's gonna take 25 more minutes for car B to meet car A after 9:45. So if I add 25 4 minutes after 9:45, so that is going to be equal to 10 o'clock and 10 minutes, which is nothing but our answer option 2, right? So suppose you've understood this question. Again, it's a previous CAT question, so it's ought to be tough, but you see the simplicity with which we are solving it. The distance between them is 5 kilometers, and they race, and it's just that you have to be very much aware when actually Ram comes back and when they meet. So actually at 9:45 a.m. at 9:45 a.m. Car B, it's sorry, Sham is something which actually starts, right? So I took it car B in throughout the question. So Sham is something which who starts at 9:45 a.m. and Ram is someone who is right here, and the distance between them is 3.75 kilometers. Now there are two parts to it. One is when actually Ram travels from here to here, and when actually he comes back, right? So there are two parts to it, and all is just calculation, and make sure you convert everything to the right units, and then you'll get your answer, right? So this was about the video. Thank you very much for watching the video. So in case you want to give me feedback on the video or anything else, so make sure you give it on perfectscores89@gmail.com. Don't forget to like us and support us at facebook.com/perfectscores. And if you wish to explore more about us on perfect-scores.com, so that'll be the place to be, right? So this is about the time, speed, distance second part video, in which we discuss relative speed, and in the first video we discuss about variations. There's more to come. We'll discuss about circular motion and everything. right? So this was about the video, guys. Thank you very much, and I'll see you in the next one.